Hi, this sequence of videos is the AQA Further Pure for January 2010 exam paper. I'm going to be trying a different format for this. I'm going to split each video into three parts. The first part will be try, and in the top right hand corner the word try will be highlighted, and the idea is that you have a go at the question yourself during this part of the video, and you need to pause it so that you can do the question. The next part of the video will be the hint section. So in this part of the video, rather than go through the question with you, I will provide you with a hint as to how you might go about tackling parts of the question. You would then pause the video and have a go using the hints that I've given you. The third part of the video will be the answer to the question, and I will go through the whole question, answering all of the various bits in full. You don't have to watch all of that. You might find that you feel like you've already got a solution, so you might want to skip to the end of that part, or you might want to go through it and see what a model solution might look like. Or you may be unsure from the hints, so you may want to watch the whole of that section so that you can understand the answers. Feel free to pause the video, and I expect you to pause the video at various places. So even in the answer section, if you feel like you can now do part of the question, then pause the video and have a go. And also, if you get to a point where you think you can finish off the question yourself, then just pause it and finish it off yourself. The idea is that you're as active as possible during these videos. Right, so question number one. So again, just to remind you, this is from the January 2010 exam paper. In this question, we've been given a 2x2 matrix, and it represents the plane transformation T, and we want to write down the value of the determinant of M in each of these cases here. So if you want to go ahead and have a try at that question first. Okay, I'm now going to provide a hint to the question. So we're asked to find a rotation, a reflection, a shear, and an enlargement with a scale factor of 3, and we want to know what the determinant is going to be in each of these cases. Now the key thing here is that we need to realise that the determinant tells us the area scale factor of the transformation. So that's how much the area has changed during the transformation. So what you should aim to do now is look at each of these and decide, has the area changed, and by what scale factor has the area changed. So if you want to have a go at doing that now. Okay, I'm now going to go through the answer of this question. Okay, so for part A, we're told that T is a rotation. Now, if I rotate an object, the area isn't going to change. So the determinant of the matrix is going to just be, because we would say the area is invariant, it's not going to change. That would be 1. For part B, this time it's saying that T is a reflection. Okay, and again, the area isn't going to change here. However, as it's a reflection, we have gone from having an area that's in the positive direction to an area being in the negative direction, as it's kind of flipped over. Okay, so for the reflection, our determinant is going to be -1. Yes, so our area scale factor is still 1, but it's negative because it's kind of facing the other way now. So that's going to be -1. For part C, this time we've got a shear, and for a shear, and in a shear we need to remember that the area is going to be invariant, and in a shear it's just when a shape is kind of skewed across a little bit, but the area stays the same, so that's going to have a determinant of 1. And part D, we've got an enlargement with a scale factor of 3, so that's going to be stretched in 2 directions by a scale factor of 3. So one direction is going to make it 3 times as big, and the other direction is also going to make it 3 times as big, so altogether it's going to be 9 times as big, the area, so the determinant of that is going to be 9. Okay, I hope you managed to get there yourself, and please join me again for the next video.